Hello everyone, I'm Bhushan Chaudhary from Uval campus Birkenfield, and today I'll provide a short summary on the scientific article named as Net Zero in the Heating Sector, Technological Optional and Environmental Sustainability from Now to 2050. The article was published in a journal named as Energy Conversion and Management, and the article discusses space and heating strategy for UK to be net zero emissions in 2050 for its heating sector. About the authors, so the article was published by two authors, that is Peter Slorach and Laurence Stamford, and their area of interest is quite similar to each other. About the content of the article, so the article first starts with a brief introduction of current heating scenario in UK. Then it discusses about the different technologies which can be implemented in future. Then it talks about the methods which can be used to evaluate this technology. Afterwards, it discusses the results in the form of tables and graphs. And finally, it's give a conclusion of the strategy to follow for 2050 for UK and the recommendation for other nations. Uh, if we look at the current heating demand, 90% of the heating demands are made by fossil fuels, which accounts for 40% of global CO2 emissions. In UK, 71% of the heating demands are required for space and water heatings, which are made by natural gas, oil boilers, and electric heaters, and that also accounts for 18% of greenhouse gas emission in UK. So to cope up with this problem, the objective of this research was to evaluate environmental impact of different heating technologies with the help of life cycle assessment tool, and the present the future scenario in 2035 and 2050 in UK space heating sector. And the ultimate objective of this paper was to have a net zero emission strategy for heating sector by 2050. The technology considered in the paper are ASHP, hydrogen boilers, and electric heating. The ASHP stands for air source heat pumps. They convert the heat from the ambient air to the water and then radiate heat into the area. The water temperature they generally rise is up to 55 degrees Celsius. Next is the hydrogen boilers. They are similar to gas boilers, but they only emit water vapors, but they can also emit NO2 emissions with a high temperature steam. And the next is the electric heating. They are simple type of convectional device, and they generally have a high mean lifetime and design life. The methods to evaluate these two technologies based on two functions. First is the heat required to produce 1 kilowatt hour of electricity for different technologies, and the second is total amount of heat needed for building heating for different technologies. And 19 criteria closely related to environmental impact are evaluated. The criteria includes land use, eutrophication, climate change, toxicity, acidification, etc. And the LCA tool used in this study is EcoInvent. It is a life cycle based inventory tool. It complies with ISO standard, and the entire value chain of heating sector is analyzed with the help of this tool. The results and discussions are like for generating 1 kilowatt hour, the gas boiler tops the category. It has lowest impact in 12 out of 19 category, but its climate potential is very high as compared to the other technologies. Similarly, the hydrogen boilers with steam reformation and electrolyzers have a highest impact in 17 out of 19 categories, but you can see the fact that in 2050 the climate change potential will be net negative, that is minus 59 for electrolysis process, even though electrolysis process requires high amount of energy than SMR. Similarly, for ASHP, it has the lowest impact in 5 out of 19 categories, and if they are hybridized with steam reformation technologies, they will be net zero by 2050. And for overall heat demand, the indigenous shale gas has a lower carbon emission than imported LNG, but extraction of shale gas takes large amount of water and produces significant amount of methane emissions. These methane emissions can be combined with steam reformation technology and then with the carbon capture technology to significantly cut down the greenhouse gas emissions. In the conclusion and the recommendation part of the paper, it gives a graphical view of the technology in future. You can see in 2035, the gas boiler still tops the list. But in 2050, there are no more gas boilers and they are replaced by the hydrogen boilers and followed by ASHP and then hybrid ASHP. Also, the total heat demand for space and heating sector is dropped by 32% and that of 2018 level due to the energy efficiency and insulation implementation and also this technology implementation. Also, if ASHP runs on renewable and other sources, it can cut down carbon emissions by 95%. And currently, the ASHP runs on HFCs such as R134A, but if they work with hydrocarbon refrigerants such as propane, then they can further cut down the emissions by 99.7%, and these are nearly equal to net zero emissions. The recommendation in these papers are this study can be replicated to the nations with similar conditions and technologies, and further research can be more on social and economical impact with the help of LCA to achieve desired goals of net zero in 2050. This is the article which I reviewed. And thanks a lot for your valuable time. And if you have any feedback, suggestion, and question, you can reach out anytime to the below email. Thanks a lot once again.